In this video I'm going to look at the different examples comparing similar solids and their surface areas, their volumes, and their scale factors or length ratios. So in the first one, notice it's giving us the ratio of the edge lengths of two cubes, and that's 7 to 8. It's going to be an important number to remember. It says the smaller cube has a surface area of 98 square inches, and it wants us to calculate the surface area of the larger cube. Well, we could probably go through and actually figure out the side lengths of the smaller cube and then use this ratio to get us to the lengths of the longer sides in the larger one, but I think we have another method here. So what I'm going to do is I'm going to write down this ratio of 7 over 8. Now, that's the scale factor, or I like to think of it as the length ratio. Now, we also have a number for the smaller cube. So the smaller cube has a surface area of 98. Well, what I'm going to do then is I'm going to write my ratio of smaller surface area over larger surface area. So 98 is the smaller surface area over, I don't know the larger surface area. In math, a lot of times what I'll do is I'll give it a variable, and I have it. Now, this 98 is a, remember, surface area ratio. Well, these two ratios are not equal because, remember, this one would be like A over B, this one's like A squared over B squared. Now, being that this one has the X in it, I want to leave it alone. So what I want to do is I want to take this length ratio and I want to turn it into a surface area ratio. So you have to think back, well, what would you have to do to the length ratio to make it become surface area? And if you think back, you remember that all you had to do was square it. So now that what used to be the length ratio is no longer the length ratio, it's now a surface area ratio. So this ratio here is a surface area ratio, this one's a surface area ratio, same problem, then those two things need to be equal. Well, now I have an equation that I can solve. It's a proportion, so I'm just going to cross multiply. If I cross multiply this way, I end up with 49x equal to, and then when I cross multiply this way, I end up with 6,272. Well, if I finish this off by dividing both sides by 49, I end up with x equaling 128. Now remember, x was the surface area of my larger cube, which is what it was asking for. Notice everything was in terms of inches and square inches. So my final answer is 128 square inches for the surface area of that larger cube. And I didn't even have to figure out how long the sides were in that larger cube. Now my next example, this one deals with a cone, and it tells us that it has a surface area of 602.88. So I have a surface area of 602.88 square inches, and it has a volume of 7,502.5 cubic inches. Now we have a similar cone, that's going to be important here. Has a surface area, well now this time the surface area is 21,703.68, and it wants us to find the volume of that second cone. So we want volume of the second cone. Well, what I'm going to do is I'm going to look at this and they say, well, I have two surface areas and I essentially have these two volumes. Now, granted, I know I don't know this one, but I think I can find it. So I'm going to write my ratio. I'm going to go 602.88 over 21,703.68. Remember, that's a surface area ratio. And then I also have a ratio, now that's very important to keep this in the same order that you did the first one, so it looks like I did smaller over bigger, so, or first over second. So I'm going to do 7,002.5 over, I don't know the volume of my second one there. And remember, that's a volume ratio. Now, I have these two ratios. Again, surface area ratio does not equal volume ratio, so I can't put an equal sign in there yet. But I'm going to look at this and say, being the volume ratio has my variable in it, I'm going to leave that one alone. I'm not going to touch it. So what that tells me is I'm going to have to take that surface area ratio and somehow turn it into the volume. Well, I look at it as there's not really a direct path to it, But I could start off and I could take the surface area and I could turn it into a length ratio or the scale factor. Now remember, if I took the length ratio and I squared it, it became surface area. So to go backwards, I could take that square root of my surface area ratio and now I'd be at a length. So if I stop right here, now that ratio would be a length ratio, but I wanted volume. So somehow I have to turn this ratio into a volume ratio. Now I think, well, if I took the length ratio and I were to cube it, then it would be a volume ratio. And that's what I just did. I cubed it. So therefore, I no longer have a length ratio. Now it's a volume ratio. Volume ratio on the left, volume ratio on the right. Those two things are going to be equal. And now I have a proportion that I'm going to be able to solve. So the first thing that I'm going to do is I'm going to cross multiply. Now when I do that, I'm going to have to take this, I'm going to take the 602.88. Why don't I just go to the calculator and I'll show you exactly what I'm going to do. So I'm going to get rid of that from before. I need to take the square root of 602. So it's second and then x squared, so now I have the square root, and it was 602.88. I'm going to put my parentheses, so now I'm taking the square root. I also needed to cube it. So then I'm going to use my little caret key or the power key, and then I have to cube it. Make sure that you get that parenthesis in there so that you do it in the right order. I'm going to push enter. So after I do that, I'm left with 14,802.88 approximately. So I'm going to write that down. I can remember it all. 14,802.88. I believe that's what it was. Let me double check. Correct. Good deal. Times x. Now equals, and now I have to do this. So I have that 21,703.68 and also the 7,502.5. Add those two numbers, and I have to multiply that. So I need to first take the square root of the 21,703.68. Oops, hit the wrong button, didn't I? Nobody told me. You take the square root, try that again, of 21,703.68. Remember, close that parenthesis, and then I need to cube it. But then I also have to multiply it by the 7,502.5, and then push enter. So I'm doing all of that at once. Now that's a pretty big number there. That E means I have to multiply it by 10 to the 10th. So I have this huge number there of, you can see it there, so I'll start writing down digits here. So I have 2398, 2398, come back here, 8664, 8664, and I think 49. Yes, that was all of them. And then the decimal point was here, so if I move it over 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I need one more zero there. There's that big number. And then I have to go through, and to finally find the volume, get my XL by itself, divide both sides by this 14,802.88 on both sides of my equation. And I'll have my X value. So I'm going to come back to my calculator. I already have this number in there, so all I'm going to do is divide by 14,802.88. And actually I can see it up there, it's a little farther than there's the 329. I'm just using as many decimal places as I can get, and then I'm going to push enter. So my final answer is this 1,620,540. 1,620, was it? My memory fails me many times. 540, comma there, comma there. And then just go out and I need to find my label because labels are very important. This was all in terms of inches. So this is going to be cubic inches for the volume of that second cone. Okay, now I have another one here. This one's dealing with regular pentagonal prisms, and they're similar, and it gives me the scale factor that's 4 to 7. It also gives me the apothem of the base of the smaller prism is 7, and the height of the prism is 10 centimeters, and I want to know what's the surface area of the larger prism. So the first thing I'm going to do is, being it's talking about surface area, I'm going to draw the net for my prism. Well, it's a pentagon as the base, which means then it's going to have 5 rectangles wrapping around, something like this. Plus 2, 4, and then here's the 5th. And then we're going to have these pentagons somewhere so what I need to do is I need to find the surface area. If I could find the surface area of this one, I could use that to then find the surface area of my larger one. So what I know is the apothem of the base is 7, so that's the apothem of my pentagon, and I know the height of the prism is 10. Well, that height is going to be right here. So really what I need to figure out is how long is each side of my pentagon. Because if I know the length of the side, I'm going to know the length of all the sides of the rectangles as well. And I'll be able to find the area of the rectangles, and I'll be able to find the area of my regular pentagons. So I'm going to draw this in to help me out. And now remember, I'm going to have to find the measure of this angle. So if I take 360 and divide it by 5, I end up with 72 degrees. But then remember, the apothem cuts the angle in half. So I need to take that 72 degrees, I need to cut it in half, and I end up with 36 degrees. So that angle in there is 36 degrees. Now I can use trig to help me find the length of the other side of the triangle, which is going to be this little black piece right here. So I look at that from the 36 degree angle. I need to know the opposite side. I already know the adjacent. That tells me to use tangent. So I'm going to do the tangent of the 36 degree angle, and that's going to be equal to the opposite side, which is what I'm looking for, called x, over the adjacent side, which is 7. Now I just need to go through and I need to solve that equation. I'm going to call this part 1, and then I will finish this up in the next video. So make sure that you watch the next video to see the ending of this problem and one more.